In this video I'm going to talk about systems of linear equations and how we can use matrices to express that. So let's say that we have a system of equations like this: x plus 2y plus 3z equals 1. Then you can have 4x plus 5y plus 6z equals 2. And the last one, 7x plus 8y plus 9z equals 3. This system may be expressed in a total matrix, where you only pick out the numbers in front of the unknowns. You can call these coefficients, and just put them in a matrix instead. So to do that, you will have something like this, and then you may also add a column with the right hand side of the equation set. And that will be something like this, and this is called a total matrix. And to solve this system of equation, you usually do so-called Gauss-Jordan eliminations on this system. Another way of dealing with matrices on systems of equations can be done by matrix multiplication. So I want you to have a look at this particular matrix multiplication. You have this matrix, and you multiply that with x, y, and a z, a column vector like this. So try to stop the video and perform this matrix multiplication and see what will be the result of that. So, assuming that you have given it a try, you may have seen that when you multiply each x with each row, x, y, and z with each row here, you will, of course, if you can take the first one, you will x on this one, then you have y on this one, and then you will have z on this one. You multiply each column piecewise on towards the row on the matrix. So this will turn out to be x plus 2y plus 3z, and then you do the same thing on the next row. Then you have 4x plus 5y plus 6z, and the last one, 7x plus 8y plus 9z. And you can observe then that this is exactly the same that you have above on the left hand side of the equation set. Then you can add another column with the right hand side, 1, 2, and 3. So that will be expressed as a new column vector, you could say, on the right hand side. So if we then continue this line of thought, and then we name this matrix, call this for the A matrix, and then we invent this to be or we call this the X vector, and then the right hand side can be expressed as another one, like a D vector like this, or a B. And then you can write up the whole system in a very compact way. You can say that this matrix system is actually expressed like this. And that is a very convenient and compact way. And here you have if you want to look at the dimensions here, it's a 3 times 3 square matrix. Here you have a 3 times 1 matrix, and here you also have a 3 times 1 matrix. this is good, but what if I had more or a different set of unknowns compared to number of equations? Well, I don't want to go into the total generalized theory here, but let's just look at an example here. So I just write up the question. Or take an example here. What if we had 4 unknowns? We call these unknowns for x1, x2, x3, and x4. And only 2 equations. How may we express this? Using matrix multiplication. Is that possible too? Yes, the answer it is yes. And if we just invent some arbitrary names on these coefficients in front of the unknowns, let's say we have a x1 plus b x2 plus c x3 plus d x4. We don't know what these numbers are, but we assume they are given in some way. On the right hand side we have e on this first equation, and then the second equation could be f x1 plus g x2 plus h x3 plus I x4, and then j on the right hand side. How can we express that using matrix multiplication? Well, it's not that difficult. It's just following the same thought that we had before. We gather all the coefficients in a sort of coefficient matrix. That will be A, B, C, D here, and then on the next row we will have F, G, H, and Y, like this. I think I will move this a little bit further down. Oh, sorry. Just want to take this a little bit further down. No, oh no, sorry. Let's see, like this. So, and then this vector x, which was the unknowns, that could be put in a column vector as before, but this time in a 4 times 1 column vector. And on the right hand side we will have another column vector, but it's a smaller dimension. So if you don't believe me on this, you can just perform the matrix multiplication and then see that this will be actually the end result of this way of expressing the matrix. But so again, this is the A matrix. This is the unknown or the solution vector x, and this is the right hand side, D. Okay, thank you very much for your attention.